Okay, so now let's talk about chapter 4. Trig functions. Okay, trigonometric functions. So first part is the angles, right? Is the angles. So what's the standard position of the angle? So you should already learn these in Math 6. So we put the initial side on the x-axis. So this is the blue line, right? This is the initial side. And then there is a terminal side. I'm going to use the red color for the terminal side. Okay, so it's a rotation from initial side to terminal side. And then we have two ways to rotate. If you rotate this way, counterclockwise, then it's positive angle. If you rotate clockwise the other way, then this is negative angle. Okay, so that's the standard position and positive, negative angle. So the vertex of the angle is in the center. We have two ways to measure the angles, right? The first way is degree measure. So if we use degree measure, a complete rotation is 360 degree. So this is 360 degree. Complete rotation, right? This is complete rotation. So this is our initial side, positive x-axis, and then this way is the positive direction. You go around once. This is 360. Okay? Yeah. So a straight angle. So that means what? You start from positive x-axis, go to half circle. That's a straight angle, right? That's a straight angle. So it's half circle, so it's 180. Okay? So now what's acute angle, right angle, and obtuse angle? So let's first understand what's a right angle, right? What's at right angle? Right angle is the rotation from positive x-axis to positive y-axis. So it's a quarter of the whole circle, of the whole rotation. Okay, a quarter of 460, so it's 90. Okay, so this is 90. So if you rotate again, you got this 180, right? When you go back to x-axis, you got 360. So this is 90, 180, and 360. So if you have an angle which is less than 90, right? So this is less than 90, then it's acute angle. If you have an angle between 90 and 180, is obtuse angle. Okay, obtuse angle. Okay, so this is degree measure. Okay, degree measure. So another measure for the circle is called reading measure. So this is the definition of reading measure. So here S is the length of this arc. And the R is the radius. So R is from center to the boundary of the circle. Okay, so this is R, the radius. So what's reading measure? Reading measure is the arc length S over the reading measure R. The radius R, then we got the reading measure. Okay, a special case. So if you have radius 1, unit circle, right? If this is a unit circle, radius is 1, then this reading measure theta is the arc length, because theta is theta over 1. Okay, so reading measure is arc length for unit circle. So now what is the length of the whole unit circle? Is 2 pi. Okay, yeah. So that's why the reading measure for the whole circle is 2 pi, because the arc length is 2 pi. Okay, so half circle, 2 pi divided by 2, so half circle is pi, and the right angle will be divided by 2 again, so it's pi over 2. Okay, yeah. So this is the reading measure. So from this picture relation, we know 360 degree is 2 pi, 180 half circle is pi, and right angle is pi over 2. So keep dividing by 2. Okay, keep dividing by 2. So this is the example to calculate reading measure. Okay, reading measure. So suppose you know the arc length is 42, so S is 42. The length on the boundary is 42. Okay, and you know the radius is 12, right? The radius is 12. So from here to the circle, the radius is 12. So what's the reading measure? Reading measure is 42 arc length divided by the radius, so is 3.5 radians. Okay, so if the radius is not 1, just divide it by the radius to get reading measure. So we already explained the whole circle is 2 pi in the reading measure and 360 degree in the degree measure. And the half circle is pi, so which is 180 in the degree measure. Okay, so we have this relation by using the picture, half circle. Okay, they are both half circle. Okay, so now for any other degrees, how can you change degrees to radians? Okay, so degree measure, so degree multiplied by pi over 180. So this is 1. So this ratio, just change the measurement for the angles. Change degree measure to the reading measure. So we will talk about more examples later. So if you are given a reading measure, okay, so you want to cancel radians, so the radians is in the denominator, pi is in the denominator. Okay, so any reading measure times this, you will get a degree measure. Degree measure times reading over 1 pi over 180, you will get a reading measure. Okay, so now let's look at examples. So first, let's look at change degrees to radians. Okay, degrees to radians. You want reading measure, so reading measure on top, pi on top. Okay, first example A. So 60 degree. How to change 60 degree to reading measure? You put pi on top, 180 on the bottom. You want reading, so reading on top. You want degree, degree on top for this pi over 180. Okay, for this fraction. So now 60 and 180, you got 1/3. So this is 1/3 times pi, so it is pi over 3. Okay, pi over 3. So the second example, 270 degree. So 270, we want reading, so reading on top, degree on bottom. Right, so now reduce, cancel the degree, reduce, both divided by 90, right, divided by 90. So this is 3, this is 2. So now we got 3 pi over 2. Okay, divided by 90. Question C is a negative degree, negative 300 degree. So you want to get reading measure, so pi on top. Okay, so first degree, degree cancelled. So 30 and 180, you cannot use 90, you use 60, right? This divided by 60, you got 5. This divided by 60, you got 3. So this is negative 5 pi over 3. Now the backward. So if we want to change reading measures to degree measures, okay? Yeah, we want to change radians to degree. So there's a typo here in the slides, right? In the slides, you are given radian measure. We want degree measure. Okay, degree measure. So first question, pi over 4. That's a reading measure. We want degree measure, so degree on top. Pi on the bottom. Okay. You want degree on top. You want radian on top. So now pi and pi canceled. We got 180 degree divided by 4. 180 divided by 4, we got 45 degree. Okay, 45 degree. B, negative 4 pi over 3. So we want degree measure. So we want degree on top. And then pi canceled. We got negative 4 times 180 divided by 3. Pre-canceling, right? 180 divided by 3, you got 60. 4 times 60, we got 240 degree. Okay, degree. And the last example is similar. So 6 is a reading measure, right? Reading measure. So now 6 is 6 times 180 over pi. Okay, so we got 6 times 180 degree over pi. Okay, so now there's in question A and B, we cancel the pi here, but 6, there's no pi there. Okay, yeah, we have to use calculator. So pi is what? Pi is about 3.14. So you just use 3.14 for the denominator. And then use calculator, you can get the answer. So it's about 343.8 degree. Okay, 8 degree. So sometimes you have to change pi to 3.14 and then use calculator to get the degree measure. Okay, so now we want to draw angles in the standard position. Okay, in the standard position. How to draw angles in standard position? So basically, we compare the angle to these 4 cases, right? So this is 90, 180, 270, and 360. If you use the degree measure. Okay, so let me do it here. So here is 0, and then if you rotate, this is 90 degree, this is 180, this is 270, and when you go back, you got 360. Okay, 360. So now if you use reading measure, if you like reading measure, this is pi over 2, this is pi, this is 3 pi over 2, and then finally you go back, it's 2 pi. Okay, it's 2 pi. So if you know how big the angle is, you can put it in the 4 quadrants. Okay, 4 quadrants. So examples. So for example, if you want to draw pi over 6, draw this angle pi over 6. If you're familiar with reading measure, you can just put it in the first quadrant. If you're not familiar with it, you can change it to 180 divided by 6. So this is 30 degree. So it's between 0 and 90 degree, right? 90 degree. So here will be, it's 1/3 of the first quadrant. So this is about 30 degree. The rotation is counterclockwise. Okay, yeah. So this is 30 or pi over 6. So now if you want to draw, let's say 7 pi over 4. Okay, 7 pi over 4. So what is 7 pi over 4? If you know it, so it's bigger than 3 pi over 2 and less than 2 pi. So it's in the middle of the 4th quadrant. If you don't know that, you just change it to degree measure, right? Degree measure. So 7 times 180 divided by 4. So this is 7 times 45 degree, right? 45 degree. So this is 315. So where's 315? So it's bigger than 270 and less than 360. Then you know it's in the last quadrant. It's here. Okay, it's here. So we have a big rotation. So this is 315 degree, or this is 7 pi over 4. Okay, over 4. So we compare any angle to these 4 special angles. Okay, to these 4 special angles, and then we draw the terminal side. Okay, so now let's draw this angle negative pi over 4. Right, negative pi over 4. So what is negative pi over 4? So this is 0. If now we need negative angle, right? If you rotate this way, so this will be negative 90. This will be negative 180, and this is negative 270. So when you go back, this is negative 360 degree. Okay, degree. So this in the degree measure is negative 45. Okay, so it's between 0 and negative 90. So the terminal side is here. The rotation is clockwise. So this is negative 45 degrees. So this is our angle. Okay, so if it's negative, you use clockwise rotation. Positive, you use counterclockwise rotation. Okay, so now let's look at two big angles, right? Two big angles. So first one is 13 pi over 4. Okay, 13 pi over 4. So again, it's positive. So we compare this angle to these four special angles, 90, 180, and 270. Okay, and 270. But when you change this angle, you can see this angle is bigger than 360. Okay, so 13 times 180 divided by 4. So this is 13 times 45 degree. This is 585 degree. Okay, so this angle is bigger than 360. So what that means? That means you have a rotation. So if you go back to x-axis, you got 360. But it's not big enough. You have to rotate, continue. Rotate, continue, right? Continue, go to here. And then you check it. So this is 180 plus 360. So this is 540. So it's still not big enough. So if you need a little bit more than that. Okay, a little bit more than that. Then you got 585. Okay, so it's bigger than 360. You just keep rotating. Keep rotating. So this is the terminal side for the angle. Okay, for the angle. So again, so first you go around 360. Not big enough. You go here, 540. Still not big enough. Continue. Okay, so if you go again, you got 60. If you rotate to here, you got 630. It's too big. Okay, it's too big. That's why the terminal side is in the third quadrant. Okay, in the third quadrant. Okay, one more example. So let's say if we have 1080 degree. So what is this angle? So first we got 360. Go around once, smaller, so continue. Go around again, 720. Or go around again, we got 1080 degrees. So we go around 3 times. That's our angle. So where is the terminal side? Terminal side is the initial side. Okay, they are both x-axis, but the angle is not 0. We rotate 3 times. Okay, 3 times. Okay, so sometimes if you know the radian measure, you can find the arc length. Okay, arc length. So we know the radian measure is arc length divided by the radius. So now multiplied by the radius, both sides multiplied by r. What do you got? You got r cancelled. You got arc length S is the product r times theta. Okay, so here is an example about finding the length, finding the arc length. So we know theta is 45 degree. And then the radius is 6. So we want to find the arc length. Okay, find arc length. So first we have to change 45 degree to radians. Okay, so in this formula, this is the definition of radian measure. So we have to change 45 degree to radian measure. So we got pi over 180. You got pi over 4 in radian measure. Okay, so now we use this formula for the arc length. So S is the radius times the radian measure. So it's 6 times pi over 4. Use calculator, you will get 4.71. Okay, Yeah, so that's an application of definition of radian measure. So now we know the angles. Let's jump to skip 4.2. The unit circle part, jump to 4.3. Right triangle trigonometry. Okay, so we will define the 6 trig functions using right triangles. Okay, you should know this in Math 6. Okay, Math 6. Okay, so these are the 6 trig functions: sine, cosine, tangent, cosecant, secant, and cotangent. Okay, cotangent. So let me draw this right triangle. Okay, right triangle. So first you have to make sure where is the angle. So this is the angle. Angle theta. Okay, angle theta. So we have the length of opposite side of theta. So this is opposite. And we have adjacent side of theta. So this is adjacent. Okay, and then the last one is the hypotenuse. Okay, is the hypotenuse. So we use these 3 sides to define sine, cosine, and tangent first. Okay, so what's sine? Sine is opposite over hypotenuse. Okay, cosine of the angle is adjacent over hypotenuse, and tangent of the angle is opposite over adjacent. Okay, adjacent. This is how I remember the definition of trig functions in right triangle. Okay, so the other 3 is you just flip sine, cosine, and tangent. You get the other 3. Okay, so you flip sine. What do you got? You got cosecant. You flip cosine, you got secant. You flip tangent, you got cotangent. Okay? Yeah. Let's look at this very easy example. Okay, very easy example. So what's the 3 sides of this right triangle? This is the angle theta. The opposite side is 3. So this is the opposite. Okay, adjacent side is 4. And then the hypotenuse is 5. Okay, so I didn't use ABC because sometimes later we will use X, Y, and R in the XY plane. Okay, yeah, so it's just use opposite, adjacent, hypotenuse is better. Okay, is better. Now let's write down sine. Sine is opposite over hypotenuse, so this is 3 over 5. Okay, so it's 3 over 5. And then cosine is adjacent over hypotenuse, so 4 over 5. And tangent is opposite over adjacent, so this is 3 over 4. Not 5. 3 over 4. And then flip them, you got the other 3. Okay, flip them, you got the other 3. So this is, you flip sine, 3 over 5, 5 over 3. You flip cosine, you got secant. You flip tangent, you got cotangent. Okay? Yeah. So that was the first special length right triangle. So we have 4 triangles that you have to remember. Okay, so let's write it down. We have 2 special lengths right triangle. Okay, so here is 3, 4, 5. That's the first one. We already did. The other one is 5, 12, and 13. Okay, you can check 3 squared plus 4 squared is 5 squared. And then 5 squared plus 12 squared is 13 squared. Okay, 13 squared. So these are integer lengths right triangle. So the other 2 are special angles. So this is special lengths. The other 2 are special angles. Okay, so first one is 45 degree, the other one is 30 and 60. Okay, 30 and 60. So what's the 45 right triangle looks like? So let me draw a better one. Okay, this should be the same length, right? Same length. Okay, so if this angle is 45, because we know the other one is 90, so this is another 45. They are the same. Two angles are the same. Okay, so what's the corresponding length? Okay, what's the corresponding length? You can use 1 radical 2 or radical 2, radical 2, 2. Okay, yeah. So 30/60 is more important. Okay, 30/60 is more important. So 30/60. So we have different angles. The smaller one is 30, the bigger one is 60. What's the corresponding length? Here is 1, 2, radical 3. Okay, radical 3. So opposite of 60. So this is 60 degree, 60 degree. Opposite of 60 is radical 3. Opposite of 30 is 1. And then the hypotenuse is 2. Okay, so remember these 4 special right triangles. We will use them later. Okay, we will use them later. Okay, so I just said for 45 degree we have 2 models. Okay, you can use either this 1 radical 2 or radical 2, radical 2, 2. You will get the same trig values. Okay, so you just enlarge this, everybody here multiplied by radical 2, you got the bigger one. Okay, the bigger one. So the trig functions is easy. You just use definition, right? So what is cosecant? Cosecant is opposite over hypotenuse and then flip it, right? Opposite 1 over hypotenuse radical 2, flip it, you got this answer. Okay, so 1 over radical 2, this is sine 45. And then cosecant 45, you flip this, you got radical 1 or radical 2 over 1, you got radical 2. If you use this blue triangle, so if you use this red triangle, you got the same answer. So sine 45 is opposite 45, opposite over that, so radical 2 over hypotenuse. And then you flip it, you got cosecant. So 2 over radical 2 is still radical 2. Okay, so for 45 degree we have 2 models. You can use this blue or red, you pick it. Okay, you pick it. So this is the 30/60 example. Okay, so this picture is good. So this picture tells you why we have 1, 2, radical 3. So if you doubled this 30/60 right triangle, you got a new bigger triangle. So for this bigger triangle, it's equilateral triangle, right? We have 3 lengths and they're all the same. So this is 2, this is 2, and that is 2. Because all these 6 angles are 60. That's why we have same length too. Okay, same length too. So this special right triangle is just half of everything, half of the whole bigger triangle. So here is 1. Use Pythagorean theorem, you can find the height here is radical 3. Okay, and then use definition of trig, you can find tangent 60. So what's tangent 60? We look at this angle 60, opposite is radical 3. Adjacent is 1, so it's radical 3 over 1. When you look at angle 30, so this is angle 30, what's the opposite of 30? Opposite of 30 is 1. So this is 1 over radical 3. Okay, and then rationalize denominator, you got radical 3 over 3. Okay, so opposite and adjacent based on the given angle. Okay, given angle. So it's always easier to find opposite angle. Okay, so what's the co-function identities? So let's look at another right triangle. Okay, right triangle. So assume this angle is theta. So we know the sum of these two acute angles is 90. So this angle, the other angle will be 90 degree minus theta degree. Okay, 90 minus theta. So now we look at the sine theta. Okay, so let's label these three sides now. So this is A, B, and C. So what's the opposite of theta? Opposite of theta is A, and then hypotenuse is C. So sine theta is A over C. But now if you look at cosine of 90 degree minus theta degree. Okay, so now if you look at this angle, so what is A? A is the adjacent side of 90 minus theta, and hypotenuse is C. Okay, so we got sine theta is equal to cosine 90 minus theta. Okay, so that's how we get the first cofunction identity. Okay, cofunction identity. So similarly, we can get tangent theta is cotangent 90 minus theta, or you reverse them, right? Or you reverse them. Cosine theta is sine 90 minus theta, and cotangent theta is tangent 90 minus theta. Okay, yeah, so sine 46 is 90 minus 46, so cosine, so it's cosine 44. You just add a right angle, so this is 90, right? Pi over 2 is 90. So cotangent, you change it to tangent, and then cotangent, you change to tangent, and then 90 minus the angle. Okay, 90 minus the angle. Then we got this is tangent 5 pi over 12. Okay, because you're looking at different angles. So A is opposite angle of theta, but is adjacent angle of 90 minus theta. So here's the cofunction identity. So we are looking at two acute angles in the same triangle. Okay, so now we will talk about trig functions, these sine, cosine, tangent, cotangent, secant, cosecant for any angle. So basically, we'll draw right triangles in xy coordinate plane. After you draw right triangle, you know trig functions, right? Yeah, so our job is draw terminal side, and based on the terminal side, we draw a right triangle. So let's look at this first example. Okay, first example. So we draw a terminal side, and we pick a point. You pick any point P on the terminal side. Okay, so how do we define the trig functions? We need a right triangle. How to draw a right triangle based on P? We draw a vertical line, not a horizontal line. This is very important. Some students draw a horizontal line. We draw a vertical line passing through P, and then we make a right triangle, right angle here, and then we make a right triangle for this angle theta. Okay, so if you assume the point P is x comma y, so what is this? Y is this vertical side of right triangle. X will be the horizontal side, the bottom side of the right triangle. So what is the hypotenuse? Hypotenuse R will be square root of x squared plus y squared by the Pythagorean theorem. Okay, so now what is sine of theta? In the right triangle, it's opposite over adjacent. So opposite over hypotenuse. Right, opposite of theta over hypotenuse. What is cosine? So it's adjacent over hypotenuse. What's tangent? Is opposite over adjacent. So it's the same definition. Okay, so the definition in the plane, in the coordinate plane, is the same as the definition in the right triangle. You have to make this right triangle, and then you see they are the same definition. If there's no right triangle, that's another story. Okay, that's a special case. So example 1. Okay, example 1. So there is a given point. The point is 1, -3. Okay, -3. So now let's try to draw the right triangle first. Okay, so where's 1, -3? So 1, 2, 3, -1, -2, -3. So this is our point. 1, -3p. Okay, yeah. So now P is on the terminal side, so I will use blue color for the terminal side. This is point P. Okay, how to make a right triangle? Again, we draw a vertical line passing through P to make a right triangle. So this is the right angle, this is the right triangle. Okay, so now let's label X, Y, and R. So what is this? Y is -3, X is 1, and R is what? Square root of 3 squared plus 1 squared. So this is square root of 10. Okay, square root of 10. So R is square root of 10. So now for this angle, where's the angle? This is the angle. Okay, I'm going to use this blue color. This is the angle from x-axis to this blue line. Okay, to this blue line. Okay, so this is the angle theta. So what's the sine theta? Opposite. Okay, opposite is -3. Okay, so here you have to remember, we're not only looking at the right triangle. We are looking at the right triangle in xy plane, right? So this side is not 3 anymore. It's -3 because it's going down. This side is still +1 because it's on the right. Okay, so when you put a right triangle in the plane, you have to use positive and negative directions. So this is sine theta is opposite over hypotenuse. So it's -3 y over r radical 10. Cosine theta is adjacent over hypotenuse. So this is 1 over radical 10. And then you can simplify that to get the answer. Okay, to get the answer. So the key is draw a right triangle and then rate the length, rate the side in the xy plane. Yeah, the other 4 functions are easier. So we just use definition for this right triangle, right? What's tangent? Tangent is opposite over adjacent, so -3 over 1. And then flip the other 3, you got the last 3 trig functions. Okay, so the key is sine and cosine. So now let's look at a new question. So suppose sine t is 4 over 5 and the cosine t is 3 over 5. So let's find tangent t. Okay, so the other 3, you just flip them, you got the answer. Okay, you got the answer. Okay, yeah. So here we don't know how big is angle t, right? How big is angle t? Okay, yeah. So first we rewrite the definition, right? We rewrite the definition. So assume here is point P. So this is xy, and then the vertical side is y. Horizontal side, bottom side is x, and this is r, the hypotenuse. Okay. So what is sine t? Sine t is y over r. Cosine t is x over r. We just rewrite the definition based on the picture. Okay, based on the picture. Now let's look at the given number. So sine t is 4 over 5. Cosine t is 3 over 5. Then what we can get? We get y is 4, r is 5, and x is 3. Okay, so we got the information here. Y is 4, x is 3, r is 5. So what is tangent? What's the definition of tangent t? Tangent is opposite over adjacent, so this is 4 over 3. Flip them, you got all trig functions. Okay, trig functions. Another example. So we got sine t is negative 2 over 3. Cosine t is radical 5 over 3. Find tangent. Okay, that was the question. Find tangent t. So we use same idea, right? You draw the picture. So here is the point P. And then this is the y, x, and r. Okay, so the position for the P is not important, right? So if you have the blue right triangle here, so this is P, so here the same thing, y, x, and r. The definition won't change. We just put the right triangle in different places, okay, different places. So again, use definition. Sine t is y over r, which is negative 2 over 3. Okay, we put negative sign on top because r is the negative sign on top. Because r is always positive. R is the hypotenuse, is the length. R is always positive. Okay, so it's negative. Numerator is negative. Cosine t is radical 5 over 3. Sorry, I should write the definition first. It's x over r, so this is radical 5 over 3. So now we know y, x, and r, right? Y is negative 2, x is radical 5, and r is 3. Okay, r is 3. So now we can draw the picture for this angle. Okay, because we already know where it is, right? So let me draw a new picture. So y is negative 2. So here's negative 2. X is radical 5. So this is radical 5, the point P, x, comma, y. Okay, so this is my right triangle. Okay, so before you find x, y, and r, we don't know where is the right triangle. Okay, you just assume it's in the first coordinate and then write down the definition for the trig functions. And then you compare the values, the given values. You know x, y, and r. You can draw the real picture for the angle t. Okay, for the angle t. Okay, so this is negative 2, radical 5, and 3. So what's tangent t? Tangent t will be opposite over adjacent. Opposite, negative 2, adjacent, radical 5. So this is the angle t. Okay, angle t. Okay, so now let's find sine of 240 degree. Okay, 240 degree. So again, we need a right triangle in the plane, right in the plane. So first 90 and then 180. So the next one is 270, is too big, so we stop here. Okay, we got the terminal side for 240 degree. And then we pick a point P here on the terminal side, any point, to make a right triangle by drawing a vertical line passing through P. Okay, yeah, so now how big is this angle? That's very important. Okay, yeah, so the rotation is first 90 and then 180, right? So this is the red one is 180, and then we got actual rotation to get 40. So this actual rotation is called the reference angle. Okay, the reference angle. So theta is 240. By drawing the picture, we know the reference angle is 240 minus the half circle, so is 60. Okay, so we know this angle is 60, so this is 30. So it's 30, 60 right triangle. What's the corresponding length for 30, 60? 30, 60. So here is 2, radicals 3, and 1. Okay, so opposite of 60 is radicals 3, and the opposite of 30 is 1, hypotenuse is 2. And you look at the position of this triangle. It's in the third quadrant. So this number 1 is negative because it's on the left. And this radical 3 is negative because it's going down. And then this 2 is positive. Okay, so the hypotenuse is also positive. So now what's sine? Sine 240 will be opposite. Negative radical 3 divided by hypotenuse 2. Okay, hypotenuse 2. So if you are given an angle, you need to find the reference angle. After you find the reference angle, you can draw a picture, right triangle, and then use definition to find the trig value. Okay, trig value. Let's do it again. Okay, so let's find tangent of 150. Okay, 150. So first we draw the angle. 150, so this is 90. And the half circle is 180, is too big, so we stop here, right? So this is 150. Okay, 150. And then we draw the terminal side for 150. And then this is our point P. So a vertical line, make a right triangle here. Okay, make our right triangle here. So P is x comma y. So here is y, x, and r. Okay, x and r. So now we know the angle is 150. We need to know the reference angle. Okay, so what's the reference angle? Reference angle is the angle, the acute angle in the right triangle. So this is theta star. Okay, so what's theta star? Theta star and this blue angle theta, if you put them together, if you add them together, you got half circle. So theta star plus theta is 180 degree for this particular example. So theta star is 180 minus theta. So is 180 minus 150. Theta star is 30 degree. Okay, 30 degree. So now this is 30, this is 60. So we got the same special angle right triangle. 30, 60. 60, 30, so 1, 2, radical 3 again, right? Radical 3 again. So now opposite of 30, so this is 1. Opposite of 60, this is radical 3, and r is 2. Okay, so now let's look at the positive or negative. So this y is in the positive half plane, so it's positive, and x is negative because it's in the left. Okay, so it's negative radical 3, not radical 3. Okay, yeah. So now what do we get? We get tangent 150 is y over x. So this is 1 over negative radical 3. If you like, you can simplify that. Okay, so next example. Okay, next example. So we know cosine of theta is 2 over 3. And the terminal side of theta is in the fourth quadrant. Okay, so we have 4 quadrants here. 1, 2, 3, 4. Okay, yeah, so the given information is theta is in the fourth quadrant. So we want to find sine. Okay, we want to find sine theta. So now let's draw the terminal side of theta. Okay, we don't know how big is theta, but we know it's in the fourth quadrant. Okay, so the picture looks like this. We have a point P here in the fourth quadrant on the terminal side, and then we draw a vertical line passing through P. We make a right angle, right triangle. Okay, so that is the picture. So now x, y, and r. Okay, x, y, and r. So what is cosine? Cosine theta, by definition of right triangle, so is the adjacent over hypotenuse, and then the given number is 2 over 3. So we know x is 2, r is 3. So now what is y? Okay, what is y? We know Pythagoras theorem. X squared plus y squared is r squared. So 2 squared plus y squared is 3 squared. 4 plus y squared is 9. Y squared is 5. So take square root. Y is positive, negative, square root of 5. So now the problem is positive square root of 5 or negative square root of 5. Now we need the picture. You see y is in the lower half plane, so it's negative radical 5. So now we have these three numbers, x, y, and r in the plane. We can find sine now. So what is sine? Sine is y over r, so it's negative radical 5 over 3. Okay, so you draw the picture first, and then use Pythagoras theorem to find x, y, and r. And then use definition of trig functions in the right triangle to find the trig values. One more example. So we will have a lot of examples here, okay, because it's hard. So we know the point P is -4, -1. So find sine theta, cosine theta, and tangent theta. Okay, tangent theta. So again, we need to draw a right triangle, right? So it's -4, -1. So here is 1, 2, 3, 4, -4, -1. So go down a little bit. So this is our P. Okay, so this is our right triangle. It's in the third quadrant. Okay, it's in the third quadrant. Okay, so this is our rotation angle theta. Okay, yeah. So P is -4, -1. So x is that, y is this. So x is -4, y is -1. Okay, -1. Okay, y is -1. So what is r? Pythagoras theorem, right? R is square root of y squared. So this is 1 plus 16. So this is radical 17. So r is radical 17. Okay, so what is sine theta? Sine is opposite over r. So this is -1 over radical 17. Cosine theta is x over r. So is -4 over radical 17. And the tangent theta is y over x, so it's -4 over -1 is 4. So a harder example, okay, a harder example. So we are given tangent is -1 over 3, and the cosine theta is less than 0. We want to find sine theta and secant theta. So let's just find sine theta. Secant theta is just flip the cosine, right? Cosine. So again, we need to know where is the terminal side. So here they said terminal side is in the second quadrant by using a table. But I don't want to use the table. I will explain how to find the terminal side in the second quadrant. Okay? Yeah. So let's write down the definition again. So what's tangent? Tangent is y over x. And we know is -1 over 3. Okay, so x and y, they can both be positive or negative. So we have two cases. One, the numerator is negative. So y over x is -1 over 3. The second case is the numerator is positive, denominator is negative. Okay, so from the first condition, tangent is -1 over 3. We got two possibilities. Okay, two possibilities. And we have another information. So cosine theta is less than 0. So what is cosine? Cosine is x over r. And we know r is always positive. So this is less than 0 implies x is less than 0. So we know x is negative. X is negative. Y is positive. So this is our case. Okay, so what's the point? P for this x comma y, P is -3 and 1. Okay, -3 and 1. So we know it's in the second quadrant now. We can draw the picture. Okay, we can draw the picture. Okay, so we know this is -3, this is 1. Okay, this is 1. So what is R? Look at this calculation. R is x squared plus y squared, Pythagorean theorem, right? So it's 1 plus 9 radical 10. So this is radical 10. Okay, so after you draw this picture, you know tangent, cotangent, sine, and cosine. They want us to find sine and secant. So what is sine? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And the secant is just flip the cosine, right? Okay, so the important part is this picture. If you draw the picture, you know the answer. Okay, you know the answer. So you need to know this quadrant. So in Math 6, they give you a table like this. Okay, so they tell you the sign of 6 trig functions. So in quadrant 1, they are all positive. Okay, so in quadrant 2, we got sine is positive. So we only look at sine, cosine, and tangent. The other 3 are the reciprocal of this 3. Okay, of this 3. Okay, so positive sine. The next one in the third quadrant, tangent is positive, and the last one, cosine is positive. Okay, so if you can remember this, is also you can also find the angle theta is in the second quadrant for the same example. Okay, because we need tangent negative, cosine negative, right? So we're looking at 3 sides: sine, cosine, and tangent. So tangent negative 1 over 3, so it's negative. Cosine negative is given, so sine is positive. There's no option there. All 3 functions are negative. Okay, so sine has to be positive. So this implies quadrant 2. And then you can draw the picture in quadrant 2, right? Then you know x is negative, y is positive, and r is radical 10, and then you can continue to get the answer. Okay, they get the answer. So if you already know this table, okay, yeah. So first quadrant, everybody positive. Second quadrant, sine positive. Third quadrant, tangent positive. And the last quadrant, cosine is positive. You can use it to find the place for the terminal side. And then draw the picture. Draw a right triangle, you got the answer. Okay, you got the answer. So some degenerate case, sometimes there's no right triangle. Right, no right triangles. For example, if P is 1.0, so that means P is on the x-axis, so P is this point. Okay, so P is 1.0. So if you draw a vertical line, there's no right triangle. Okay, there's a right angle, but you cannot make a right triangle because the terminal side is here. Okay, yeah. So P is on the terminal side, there's no right triangle. So for this case, you can still use the definition of trigs, right? So what is sine? Sine is y over r. Cosine is x over r. So what is r? R is square root of x squared plus y squared. So x is 1, y is 0. So for special cases, you just don't look at the right triangle. Use this definition to find x, y, r, and then sine, cosine. Okay, so there's no right triangle. Okay, no right triangle. So if you plug in here, so what is r? R is 1 plus 0, so square root of 1 is 1. So r is also 1. So what is sine? Sine is y over r, so 0 over 1 is 0. What's cosine? Cosine is x over r, so 1 over 1 is 1. Okay, so this is the special case. Okay, this is the special case. So next time we will talk about unit circles. So we will talk about these special cases again in the unit circle. It will be much easier to understand.